Hey student, today I'm excited to show you the power rule, which is going to save us a lot of time when we take derivatives. Looking here, we're going to still use the definition of a derivative in order to find the power rule. Let's take a look at what we've got already. I've got this table here, y values, x to the negative 1, x to the 0, x to the 1. These are all functions I want to take the derivative of, and then I'm going to put their derivatives here. We've already taken the derivative of x squared in the first video, and that was 2x. So I wanted to start with x to the 1, which is just x. So that would be x plus h minus x all over h. We can cancel our x's. This is the limit as h goes to 0 of h over h. H over h is just 1. So this will just be 1 because the limit as h goes to 0 of 1 is just 1. So there we are. And I'm going to do something kind of interesting. I'm going to write 1x to the 0 next to it, okay? Because x to the 0 is just 1. I'm not changing anything by putting that there. So I'm going to put that there for now. Speaking of x to the 0, we have an x to the 0 here that I want to take the derivative of. The limit as h goes to 0 of x plus h to the 0 minus x to the 0 all over h. Now, I've just mentioned this, that x to the 0 is 1. Anything to the 0 power is 1. So to simplify this, we have the limit as h goes to 0 of x plus h to the 0 is just 1, minus 1 over h is 0 over h, or just 0. This limit would just be 0. Okay, so let's write that here. Let's say 0. And I could write x to the 0 here, but I'm not going to. I'm just going to write 0. Let's move on to x to the third. We have the limit as h goes to 0 of x plus h to the third minus x to the third all over h. And you all might not know off the top of your head how to expand x plus h to the third power, but it is x to the third plus 3x squared h plus 3x h squared plus h cubed minus x cubed all over h. And we can cancel. X cubed will cancel with x cubed. 3x squared h, well, all of these terms have h in them, so we can go ahead and cancel that h. And that would be h squared. And then when we plug in 0 for h, the only term left will be that 3x squared. 3xh would become 0, and h squared would, of course, be 0. So x cubed, the derivative of that is 3x squared. And we can go further. We have x to the negative 1. In order to do that, we take the limit as h goes to 0, 1 over x plus h minus 1 over x all over h. Now you might see a pattern. You might not need to pay attention to this last one. You might already see the pattern here on the right, but it doesn't hurt for us to do this. So we'd multiply by x over x and x plus h over x plus h. Okay, so what would we have here? We'd have x over x plus h times x, and we'd have the same denominator, minus x plus h all over h. Oh, don't forget the limits. H goes to 0. Okay, these x's will cancel. We'll be left with a limit as h goes to 0. We have negative h on top. And I'm sorry, this one is kind of a mess. X plus h times x. And we're dividing by h, or we're multiplying by 1 over h. The h's will cancel. And so we'll be left with, once we plug in h is 0, we'll be left with 1 over x squared. Negative 1 over x squared. Or negative 1 times x to the negative 2. You might be able to see the pattern. I'm going to add a 1 here, so we have 2x to the 1. Now I want you to look, if you haven't seen the pattern yet, we're going from x to the third to 3x squared. We had a 3 up here. Now we have a 3 in front, and it's x squared. If we take the derivative of x squared, we had x to the second power. That 2 comes in front, and we have x to the 1. Same is true for x to the 1. We have a 1 in front, and then we have a 0. So it looks like no matter what power we have, we bring down that power. For example, x to the negative 1, we have a negative 1 in front, and then we subtract 1 from the exponent. So x to the negative 1, we bring down the negative 1, and then we subtract 1 from negative 1 to get negative 2. This works for everything. If we have x to the 0, this still works. We bring down the 0, and we could say that this is x to the negative 1, but it's 0 times that, so it's just 0. So our general rule is if we're taking the derivative of x to the n, the derivative is nx to the n minus 1. This is the power rule. So anytime, even if we're adding, even if we had x plus x squared, each part of that, we can use the power rule. We can bring down we can say 2x plus 1 would be the derivative. We'll get into that in the next video, but this works for every single exponent, a square root, a rational exponent, everything. Okay, so we'll put this to use in the next video. Stick around.